5, 4, 3, 2, 1.
Hello everyone! Welcome back to another video. My name is John Derek Ocalcetas, and for today's video, I will be teaching you how to write and name alkanes. But first, let us know what is alkanes. Alkanes are a group of hydrocarbon compounds that contains carbon-carbon single CC bonds and carbon-hydrogen CH bonds only. Alkanes have general formula of CnH2n plus 2, where N is the number of carbon atoms, N equals to 1, 2, 3, and so on and so forth. Their names end in ane or ane, since alkanes are the only hydrocarbons that contains purely single bonds throughout their structures. They are classified as a saturated hydrocarbon. Alkanes may come in two forms, namely straight chain and branch chain. Straight chains alkanes can be seen as a continuous row of carbons, where all carbons are connected to another carbon by single bonds. Each carbon satisfies octet and forms 4 bonds. Hydrogen atoms bond to these carbon atoms to fulfill the octet requirement. An example of a linear alkane is butane, a 4-carbon atom alkane whose structure is shown below. On the other hand, branch chain alkanes are composed of a parent chain and substituents. The parent chain is defined as the longest straight chain alkane present in the hydrocarbon structure. Substituents are alkyl groups attached to one or more non-terminal carbon atoms belonging to the parent chain. An example of a branch alkane is isopropane, whose structure is given below. Now, since we know what is alkanes, let us move on to our topic, which is naming straight chain alkanes. Straight chain alkanes can be easily named with the first part of its name representing the number of carbon atoms, and the suffix ane or ane, representing the hydrocarbon group alkane. For example, methane. Methane can be analyzed with defining one carbon in the compound, and ane or ane representing that the compound is purely an alkane. Below is the list of straight chains alkanes from 1 carbon to 10 carbon atoms. An alkane with 11 carbon atoms is called andecane, C11H24, while an alkane with 12 carbons is called dodecane, C12H26. The process of naming continues by attaching the following prefixes to the base word decane, which represents the 10 carbon alkane. These are examples of list of number of carbon atoms, which are 11, 12, 13, and so on and so forth. And so, the process is repeated for 20 carbon atoms and 30 carbon atoms, but the base alkane name is changed to eicosane for 20 carbon atoms and trioctane for 30 carbon atoms respectively. Now, let us move on in writing straight chain alkanes. To illustrate straight chain alkanes, we can make use of the 3 main structural methods, namely condensed, calculate, and skeletal structure. In writing a condensed structure, only the symbols for carbon and hydrogen and its subscription are shown. Hence, the absence of line bonds. For example, when writing the condensed structure for butane, the first carbon will have 3 hydrogens bonded to it. Thus, this unit will be written as CH3. The second carbon, which will have 2 hydrogens, will be written as CH2. The third hydrogen or carbon and its hydrogens will be written as CH2 also. And the fourth carbon and its hydrogen will be written as CH3. When completing the whole structure, butane will be represented as CH3, CH2, CH2, CH3. The calculate structure, on the other hand, is drawn by explicit writing the symbols of each atom and the bonds that exist between 2 atoms. It is also comparable to drawing the Lewis structures of inorganic covalent compounds. Lastly, Alkanes can also be drawn through skeletal structures, also known as line angle formula. They are represented by line segments connected through a zigzag direction. Endpoints represent carbon atoms, while the line segments are the bonds between carbon atoms. Note that in writing skeletal structures, the symbols of carbon and hydrogen are not shown, and all hydrogen atoms bonded to carbon atoms are omitted for the purpose of simplification. The zigzag direction of skeletal structures is distinct to skeletal structures as it signifies the valence bond model of each carbon atom. These are examples for line angle formula of straight chain alkane. These are examples of condensed structure for straight chain alkanes. Now, let us try some examples for Kekulé structure, skeletal structures or line angle structures, and condensed structures for straight chain alkanes. And now we're here. Now let's start some examples for straight chain alkanes. Let's start with example number 1, which is now let's name this. It's called butane. Now let's move on to another one. This is 1, 2, 3, 4, 5, 6 carbons. So it's called hexane. Let us move on to our final example, which is it has 1, 2 carbons, so it's called ethane. Now, let's move on in writing straight chain alkanes. Let's start with octane. Let's write it in Kekulé, condensed, and line angle structure. For Kekulé form, it is this is the Kekulé form of an octane. Now let's move on to the condensed structure of an octane. It is CH3. This is the condensed form of a octane. Now let's move on to to the line angle structure of an octane. This is the line angle structure of an octane. Now let us move on to example number 2. Let's find the condensed, calculate, and line angle structure of a butane. This is the calculate structure of a butane. This is the calculate structure of a butane. Now let us move on to the condensed structure of a butane. It is CH3, CH2, CH2, and CH3. This is the condensed structure of a butane. Now let us move on to the line angle structure of a butane. So it has 1, 4. This is the line angle structure of a butane. And now let us move on for our last topic, which is branch chain alkanes. Naming branch chain alkanes. Branch chain alkanes exist as molecules with alkyl substituents attached to the parent chains. Alkyl groups are formed by taking out a hydrogen from a carbon atom in an alkene, thus turning these groups into unstable molecules. To return into stable form, alkyl groups bond to a bigger chain of alkanes, which then result to the large molecule having branches. These are examples or some examples of alkyl groups. This is the basic technique in naming branch chain alkanes, which is the location, prefix, parent chain, and suffix. To properly designate the alkyl substituents, the carbon atoms in the parent chain are numbered starting from a terminal carbon atom. Each number is called a locant. The chain can be numbered starting from either terminal end, but the preferred numbering scheme should designate a lower locant to the alkyl substituent. And now, let us move on in writing branch chain alkanes. Similar to straight chain alkanes, we can write the skeletal structure of branch chain alkanes when given only their names. We can follow the steps discussed in naming branch chain alkanes, but this time we will work backwards from the alkane names. Branch chain alkanes have number in their chemical names, which represent the carbon atom to which the alkyl substituents are connected. Each substituent gets a number or a locant. Multiple substituents of the same identity are represented with prefixes such as di, tri, tetra, and so on and so forth. Let us try some examples for naming and writing branch chain alkanes. Now let's try some examples for naming and writing branch chain alkanes. Let's start with example number 1, which is Now let's try naming this. Since the parent chain is butane, now let's add this 2, which is CH3 means methyl. So it has 2 methyl, so we will name it as 1, 3, methyl. It is named as 1,3-dimethyl butane. Now let us move on to example number 2, which is naming Now let's try naming this. Since this is 1, 2, 3, 4, 5 carbons, this is pentane. Now let's try naming these two. This is 1 and 2, 3, 4, 5. This is 1, 5. And these two are ethyl. So these two are dimethyl. Diethyl pentane. So the name of this structure is 1,5-diethyl pentane. Now let us move on to example number 3. Now let us find the pairing chain. This is 1, 2, 3, 4, 5, 6 carbon. So it is hexane. Now let's add this. Since this is CH3 and CH3, so this is methyl. So 1, 1 dimethyl. And this is 1, 2, 3, 4. Propyl hexane. This is the structure of 1,1-dimethyl 4-propyl hexane. Now let us move on in writing a branch chain alkanes in calculate, condensed, and line angle form. Let's start with 2, 3, trimethyl pentane. The calculate form of 1, 2, 3 trimethyl pentane is this is the calculate form of 1, 2, 3 trimethyl pentane. Now let's find the condensed structure. So it is CH2, CH3, CH, CH3, CH, CH3, CH2, CH3. This is the condensed structure of a 1, 2, 3 trimethyl pentane. Now let's find the line angle. Since it is pentane, 5. This is the parent chain of the line angle. Now let's add the 1, 2, 3 trimethyl. This is 1, 2, 3. This is the line angle or line structure of a 1, 2, 3 trimethyl pentane. Now let's move on to example number 2 of writing branch chain alkanes. Our example is 1, 5 diethyl hexane. So H, C, hexane has 1, 2, 3, 4, 5, 6 carbons. This is the calculate form of a 1,5-diethyl hexane. 1, 2, 3, 4, 5, 6. Now let's find the condensed structure of a 1,5-diethyl hexane. So it is CH2, CH2, CH3, CH2, CH. This is the condensed structure of a 1,5-diethyl hexane. Now let's find the line angle structure. One, two, 3, 4, 5, 6. Since it's 1 and 2, 3, 4, 5. This is the line angle structure of a 1,5-diethyl hexane. Now let us move on to our final example, which is example number 3. 1, 2 dichloro 3 methyl heptane. Now let's find the calculate, condense, and the line angle structure of a 1,2 dichloro 3 methyl heptane. 2, 3, 4, 5, 6, 7. It has 1, 2, 3, 4, 5, 6, 7 carbons since the parent chain is heptane. Now let's add the 1, 2 dichloro. Chloro means chlorine. 1, 2. Let's add the 3 methyl. Now let's complete the structure. This is the calculate structure of a 1, 2 dichloro 3 methyl heptane. Now let us move on to the condensed structure of a 1, 2 dichloro 3 methyl heptane. CH2 Cl CH Cl CH CH3 CH2 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 CH3. This is the condensed structure of a 1,2-dichloro-3-methylheptane. Now, let us move on to the line angle structure of a 1,2-dichloro-3-methylheptane. So the parent chain is 1, 2, 3, 4, 5, 6, 7. This is the parent chain, which is heptane. Let's add the dichloro. Cl and 2 Cl. 3. Let's add the methyls. This is the line angle structure of a 1,2-dichloro-3-methylheptane. And that's it for today's video. Thank you for listening and watching. I hope you liked the video. Please like, share, and subscribe for more updates regarding this video. Bye! Thank you!